Hi everyone. In this video we're going to look at standard form and vertex form for a quadratic equation. We'll compare the graphs and try to determine what the equations can tell us about the graphs of these equations. Alright, so quadratic functions are necessary to start talking about graphs. So these are very similar to quadratic equations, but we are now showing a relationship between two variables like x and y, or in function notation, x and f of x. So remember that f of x is just a different way of saying y, and this is basically saying that we have a function of x. Alright, so here's standard form for a function. Just the only difference here from the equation is that instead of having this equal to 0, we now have f of x equals. Right. So we're kind of widening this up and looking at different possible values for this expression. Right? So rather than just looking at a specific one, 0, we're now saying, all right, well, that second variable, the y, could be any value. And then vertex form looks like this. F of x equals a times the quantity x minus h squared plus k. Right. So the goal for this video is to look at a couple graphs of some quadratic equations and try to determine what these coefficients tell us about the graph. So what do A, B, and C tell us? And then can we learn anything from A, H, and K? Alright. So here are some examples, and we can graph each of these quadratic functions, and let's see if we can find the vertex and the x and y intercepts. So I'm going to do this second one for you, and then I will leave the other two for you to graph on your own and use and see if you can see the same types of patterns and information. Alright, so here's a graph. If you'd like to make your own, this is desmos.com/calculator. And there's also an app as well, so you can access this either a computer or a tablet or something like that. Alright, so what I've done is just typed in, there's a little on-screen keyboard that I used, and I typed in the quadratic function, and then the graph displays on the right. Okay, now I can use these arrows to hide the equation that I typed to see more of the graph, and you can use scrolling or these plus and minus keys to kind of zoom in on the graph. Alright, and you can see different portions of it. So I've adjusted this one so that we can see the vertex and the x and y intercepts. So you may recall, now that you see the graph, all quadratic equations look like this type of a shape, and this is a parabola. Okay, so we have this arced shape, this parabola. There's a highest or lowest point, right, in every parabola. So parabolas can face this direction or this direction. Okay, and then there's either a minimum or a maximum point. So in this case, we have the lowest point, we have a minimum point, and that point is called the vertex. Okay, same thing if it was the highest point, that's still called the vertex. And then from there, the parabola continues to widen. Alright, so we know for sure that this shape never kind of curves back in on itself or anything like that. It's always going to be infinitely getting wider. Alright, so what are the coordinates of the vertex? Well, the nice thing about this Desmos type of graph is that you can just tap on different points. Right, so you can either click if you're using a computer or desktop. If you're on a tablet, you can just use your finger or stylus and tap that point. And alright, I've already done that and taken a screenshot, so the vertex has coordinates 3, 1. X-intercepts. Okay, so remember that x-intercepts are points that intercept the x-axis. So they're points in the form number as the first coordinate and then 0 for the y-coordinate. So it would be something along this axis. However, this parabola dips to a lowest point that is above the x-axis, so it never actually touches the x-axis. So in this case, there are no x-intercepts. All right, so x-intercept, none. How about the y-intercept? Right, well, that would be wherever the graph crosses the y-axis. Okay, so this is the y-axis, this is x. And I do have one point where that happens. Okay, and remember or y-intercepts always have an x-coordinate of 0. All right, so there it is. It's the point 0, 19. So now the question is, can you see any of this information from the equation? All right, just looking at it. All right, so you may want to try those other two on your own, see if you see a pattern, right? And pause here if you want to try that. And now I can see from this graph that 0, 19, right? That's not really evident from this equation, right? So I don't know that I can tell just by looking at it that the y-intercept was 19. Similarly, I don't think you can tell just from the equation that the x-intercept, that there is none, right? It would take a little bit of deductive work to figure that out. The one thing that I think you can see right away is the vertex, 3, 1, right? So notice we have a 3 and a 1 in this equation. All right, and that will happen every time you look at an equation that happens to be in vertex form. All right, so all of these that we looked at, these are all in the form a times x minus h squared plus k. Right, even x squared up here, because I can think of this as 1 times x plus 0 squared plus 0, and that's still in vertex form. All right, so it turns out that we can tell the vertex by looking at h and k. All right, so the minus sign here is part of the equation, so you just do the opposite of whatever number you see in parentheses. Okay, so this minus 3 here, it's the 3, that's the h. And then k is whatever number is either added, or if it was subtracted, then it would be a negative outside of the parentheses. So k is a positive 1. And so h and k are the coordinates of the vertex. So I think you can see why this is called vertex form, and that's because the vertex is apparent from that form of the equation. All right, what about standard form? So let's look at this third one. F of x equals negative 3x squared plus x plus 10. All right, so here's a graph, and I've tapped on some of the points so that we can see the intercepts and the vertex. All right, now these are rounded values if you see decimals. So like this one, this is negative 1, and it was probably 0.66 repeating, and we just rounded that off to 7. Right, so this isn't going to display more than just a couple decimal places. Same thing up here. This is probably 0.166 repeating, etc. So we have some rounded values. All right, so the vertex. All right, this time I have a maximum point, and the vertex is, the rounded value. All right, of 0.167, and then 10.08 for the y-coordinate. X-intercepts, well, I have two of them. I have one at negative 1.667, and then I have another one, and this is an exact value at 2. And then finally the y-intercept. This one's hidden behind the vertex there, but this one had coordinates 0, 10, and that's the y-intercept. Alright, so this is an equation in standard form, not vertex form. So now let's look at this one and see, can we tell from this equation any of these key features of the graph. All right, well, I definitely don't see the coordinates of the vertex like I did in vertex form. I don't see the x-intercepts. However, there is this connection with the plus 10 and the fact that the y-intercept was a 10. Right. So if you try some of the other ones, right, try graphing x squared and 2x squared minus 12x plus 19, and see if you notice a pattern. And it turns out that this value, this is c, right, in standard form, ax squared plus bx plus c. And it turns out that c is always the y-intercept. Right, so that's one nice thing about using standard form. All right, now how do we find the vertex or the x-intercepts from this form? Or in vertex form, how do I find the y-intercept? Well, all of those things are things that we can do. It just takes a little bit more work. So we'll talk about those over the course of the next few videos. All right, so we'll pause there. Try graphing those other equations on your own and see if you notice the same patterns that we've talked about.